inverse functions. And I've highlighted the next 3 classes in orange here because you have something coming up on all 3 of those classes. So Monday, project 2 is due. So that's the transformations project. Remember, in your 2 grading options, one of them includes projects and one of them doesn't. So if you are planning to do the test light option where you want your tests to count a little less, make sure you get that project in. Wednesday, quiz 4 is due. I'm going to give it to you on Monday. Take-home quiz, it'll be due Wednesday. And then Friday is test 2. Test 2 on classes 12 through 23. Yeah, next week. Yep. Okay, so let's go over the preview exercises together. If I want to solve for y in terms of x, so I want to have y equals some stuff with x's in it, what do I do first? Subtract 9. Right, so I've got x minus 9 equals 4y. Then what do I do? Yep, divide by 4. I want to have y by itself, so I divide by 4. Those 4's cancel. And you get y is x minus 9 over 4. Good. Equals y is the same thing. So the concept of inverse may be more familiar to you than you realize. So if you start with a bare foot and you put your socks and shoes on, right? You put it on your sock, you put on your shoe, you tie your shoe, right? What if you want to undo that? How do you take your shoes off? What do you have to do first? Untie your shoes. Then remove shoe. Remove shoe. Then remove sock. Right? And you end with a bare foot. Okay. So what do you notice about the order of the things you did versus the things you undid? They're inverse. Yeah, I reversed the order. So it went put on your sock, put on your shoe, tie your shoe. To undo it, you had to do the reverse order to undo it. Okay, so order reversed. All right, so math undoing processes work the same way. So we call these inverse operations. One operation undoing another. So if you start with a 2 and multiply by 3, you get a 6. If you want to undo that, you divide by 3, right? Because undoing multiplication is division. So you divide by 3 and you end with a 2. So we call this a round trip, right? When you do an inverse operation in mathematics, we get back to where we started, or we make a round trip. So let's think about undoing or reversing to find the inverse of the following. So you want to start by subtracting 1 from x, multiply the result by 3. So to subtract 1 from x, you start with an x and you write minus 1. And then multiply the result by 3. So I have 3 times x minus 1. So to undo, we're starting with 3 times x minus 1. And our first step is that we need to divide by 3, right? Because I'm doing the reverse order of what I did. So the last thing I did was multiply by 3. So that's the first thing I should undo. So I divide by 3. And those 3's cancel and you get x minus 1. And then to undo the minus 1, you plus 1 and end with an x. Good. So that's a really good intro to our inverse discussion for today. So let's say I have a function h equals f of t, which is 6 plus 2t, and it represents the height of corn seedlings in inches t days after they're planted. So I'm going to make a table of values for f of t over the domain 0 to 3. So I just want to plug these t values into my formula and get the heights of the corn seedlings. So at t equals 0, what's the height of my seedling? 6 inches. Yeah, when t equals 1, 8 inches, and then 2, 10, and 3, 12 inches. So I want to write a set of ordered pairs t comma h that comes from this table. So it's just 0, 6, 1, 8, 0, 6, 1, 8, 2, 10, and 3, 12. So let's say this particular function is not very helpful to me, right? Let's say I instead of figuring out the height after t days, what I'd really like to know is how long t it will take for the height to reach a certain level h. How would I find it? Yeah, so inverse, opposite, solve for the other variable, right? So I'd start with the formula I have, h equals 6 plus 2t. Right, so my input is time, my output is h, but I'd like it to be the opposite. I'd like to be able to input the height of the seedling and the function tells me how long it will take. So I just want to solve this thing for t. So just like we did earlier, I'm going to start by subtracting 6. So I get h minus 6 equals 2t. Divide both sides by 2. So I get t is h minus 6 over 2. So in this equation, now h is the input and t is the output. So my points are going to look at like h comma t's instead of t comma h's. So we switched the roles of the variables. So I'm going to create a new table. My old table was t comma h. I had a formula for my function f, and I plugged in t's and got h's. But now I'm going to do the opposite. I have h's, and I want to plug into my new formula and get the t's. Okay, so if I put a 6 into that formula for h, what do I get for t? 0. If you put an 8 in for h, what do you get? 1. If I put a 10 in there, 10 minus 6 is 4. 4 over 2 is 2. If I put 12 in, 12 minus 6 is 6. Over 2 is 3. So the set of ordered pairs, if I write it as h comma t instead of t comma h, is going to be 6, 0, 8, 1, 10, 2, and 12, 3. All right, so what do you notice about f and g, right? Here's f, my original function. Here's g, where I solved for the other variable. What do you notice about their tables? Yeah, they're just, their variables are just inverted, right? So the input and output just switched. Which normally we would call x and y, but in this case we were calling them t's and h's. So we call these two functions 6 plus 2x and x minus 6 over 2, which are the two functions we were just working with. I just switched from t's and h's to x's and y's. Okay. We call those two functions inverse functions. And the fact that g is the inverse of f is expressed by renaming g as what looks like f to the negative 1. It does not mean f to the negative 1. You just read it as f inverse. And it's related to the fact that the very first kind of undoing thing that we think about in arithmetic is often multiplication and division. And what does 5 to the negative 1 mean in arithmetic terms? It means 1 over 5, right? So we think of 1 over 5 as the multiplicative inverse of 5 because they undo each other, right? 5 times 1/5 gives you 1. They undo each other. So that's why we use this to the negative 1 notation. It does not mean to the negative 1, though. All right, so usually we would write f of x is 6 plus 2x, and instead of g of x, we would call the other function f inverse of x minus 6 over 2. All right, so here's the really big idea written all out formally. Okay, two functions, f and g, are inverses if when you compose them, Remember composing from Wednesday? When you plug one into the other, you get x back. So think of this as running two function machines in succession, right? Just like we did with composing, but the second machine undoes whatever the first one did, right? Because G and F undo each other, right? So what you end up with is X, right? So here's F. Here's F inverse, right? So you put an X in here. What comes out is F of X. You dump that into the F inverse machine, and it just undoes what the first machine did, right? So it just takes F of X and it puts it back to an X, right? So we think of inverses are two functions that when you compose them, when you run the function machines back to back, you make a round trip. The two machines just undo each other. So here's another way to visualize it. If you start with an X and you apply a function G, your result is G of X. If you apply the inverse function, which we're calling F here, you end back at an X. And then also you can do the order in either way. You can apply F first and then G. If two functions are inverses, the order that you run the two machines doesn't matter. You get a round trip no matter what. All right, that's it. You get some activities.